these are some estimates of each component, and just if you focus on ocean evaporation, this is in cubic kilometer of storage per year, or so many thousand cubic kilometer per year. So a few numbers to see here, that ocean evaporation is about 400 cubic kilometers per year, and a lot of it just falls back at precipitation, as precipitation over the oceans, but a lot of it, about 40 thousand cubic kilometer per year, it's transported overland, and there is also evapotranspiration occurring, about 73 units here. So that combined gives precipitation over land, it's about 113 units. So at any time, atmosphere over year average holds about 12.7 units, or as we saw earlier, about 12,000 cubic kilometer is held in the atmosphere. And this recycling time, when water vapor goes into the atmosphere, it condenses as clouds and falls back as precipitations, is usually 8 days. Although water cycle itself varies on diurnal timescales to multi-decadal timescales, residential time of water molecules in the atmosphere is close to 8 days. So next slide, please. Okay, so now we saw these estimates, and that's what they are. They are estimates based on multiple observations, because as we saw, there are several components: water vapor, so evaporation, then there are clouds, precipitation. All these are measured in different ways, and evaporation, evapotranspirations cannot be even measured directly. They are calculated from a number of parameters. So this graph here shows that observing the atmospheric water cycle components from ground-based measurements, these are rain gauges, radiosonde, which measure humidity in the atmosphere or water vapor content in the atmosphere, and these are oceanic floats that can provide winds and temperature measurements that can be used in calculating evaporations. These are point measurements. They are there, and they are used for estimating these water cycle components. As you can see, they're non-uniform, and from place to place, instruments can be different, so their calibration properties, their accuracies can be different too. So global estimates based on ground-based measurements are sometimes quite uncertain or inaccurate. Next, please. Okay, so then during the last couple of decades, there have been a number of satellites, and this slide specifically shows a group of NASA Earth observing satellites which are used for observing overall total global water cycle, but the atmospheric part, of course, is observed very effectively as well. And advantages of Earth observing satellites over ground measurements are that they provide large-scale global observations where there are no ground data available, and they are consistent. So because it's the same satellites, they fly over different regions, region to region, more or less it's the same observing technology and technique are used. So they're more uniform compared to instruments which are placed in 2 different locations. So observing atmospheric part of water cycle is very challenging, and especially because it has geographical variations, and space and time variations are quite large. Water vapor moves quickly. Precipitation has time scale that can be very like thunderstorm to all baroclinic or synoptic frontal system. They all have different time and space scales. So observing water vapor, precipitation, clouds on these timescales, it's sort of challenging. Next, please. So that is where satellites have been quite useful, especially for the last decade or so. Tropical rainfall measuring mission, Terra and Aqua satellites, which were specifically designed to observe atmospheric part of water cycle. In addition, there are satellites. Landsat is a long flying mission, and GRACE. So all these satellites in combination, they do provide excellent observations of entire global cycle. So what we want to see next is some of the mean maps based on some of these satellite measurements, how atmospheric water cycle components look when you look through these observations. Next, please. Okay, in addition, we talked about ground-based observations, satellite observations, and a very powerful tool to study water cycle is combining remote sensing and surface observation in modeling framework, so that you have a number of parameters which are not just observed but also calculated, which are not directly observable, like evaporation and evapotranspiration. They are calculated quantities. So is runoff and stream flow